Hello future scientists, and myself Mr. Egg.
Myself Miss Egg, and this mean little guy's wife.
Darling, please do not get mad at me. Do you know why she is mad at me? Because she did not understand quantum physics as much as I do. Ha 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 ha.
Moron, just shut the fuck up, you nerd.
I am sorry, my darling. Let me teach you quantum physics in an easy way and way that you understand. Imagine, after a hard work day, on your way home, you decide to enter a bar, you order some fresh drink with ice. Meanwhile, you lit a cigarette to relax. As soon as you put it between your teeth, bam, it vanishes. What the hell? You're wondering, looking around, but you can't find it. Just then, your drink arrives. It is still very cold and has ice cubes in it. Perfect for the hot day outside. As you try to drink from it, the ice cubes start to giggle around inside the glass by themselves, as if you've shaken it powerfully. But you didn't. Suddenly some ice cubes fall through the glass on your shirt. You quickly stand up, thinking a demon possessed your drink. You leave it on the table and rush to the exit. As you try to get out through the door, you realize it is just painted on the wall, there is no door. You look at the other visitors, and see how they simply walk in and out through the walls. Yes. Probably the place is haunted, but scale this bar down to the size smaller than that of atoms, and it isn't so strange anymore. These seemingly paranormal events just described, happen there all the time, in the quantum world.
Which is very, very small in size and cannot be seen from your eyes.
Yeah, that's right.
You know which is smaller than that?
No, what is it?
Your dick.
Well, that is very misleading, unintentional for your stupid brain, so let's see more about quantum physics. Okay, so to start off, we'll speak about the double slit experiment. You probably realize that light is both a wave and a particle through experimental research. When you were intelligent, which does not exist, but scientists arrived to this conclusion, is a really interesting story. They used a laser which was shooting photons at a photographic plate, which recorded the position of the arriving light. In between the laser and the plate, they placed a barrier. First time, on the barrier, they opened a slit on the left, and as expected, the photographic plate recorded just a line on the left, with an intensity corresponding to a wave. Scientists repeated the experiment on the right slit, a line on the right, then they tried with the both slits open. As everyone might expect, there has to appear two lines on the screen. However, to everyone's surprise, an interference pattern was recorded. Scientists tried to shoot individual photons, one at a time, and still, after some time, they got the same pattern. They discovered that the photon, at the slit intersection, divided in two, and went through both slits at the same time, and then interfered with itself, only to form that pattern. This time, physicists tried to measure the path of the photons, to understand what's going on. Once they started measuring, the photon behaved as a simple particle, went just through one slit, and after some time, the screen recorded just two lines. What's going on here? Did the photon intentionally change its path when we observed it, to hide and cover that Illuminati actually governs the particles and all the forces in the universe? Probably not. And that leads us to our next mystery of the quantum world, the uncertainty principle. Introduced first in 13.772 billion years after the Big Bang, or so that you could understand. In 1927, Annus Domini, by the German physicist Werner Heisenberg, the uncertainty principle states that we cannot know for sure both the position and the momentum of a particle at the same time. The more precisely we measure the speed of a particle, the less we know about its position, and vice versa. An analogous explanation is this: imagine a car going on the road. To know its precise location, you must stop time, go and measure it. While you do this, you can't know its speed. Try and do the opposite, stand and measure its speed, and you don't know its location. Actually, you do approximately, but on the subatomic level you can't. Let's return to the double slit experiment. The way the particles' behavior changed when we started to observe them, leads us to the observer effect, somewhat related to the uncertainty principle, that says that, by observing a particle, and in this case, we were shooting photons, via the quantum interactions of the particles, it will be affected by our measurements. Imagine that you are checking the pressure in an automobile tire. This is difficult to do without letting out some of the air, thus changing the pressure. That's why, by measuring the photons, they changed properties and didn't behave as a wave anymore, just a particle. Okay, for the next trick we need a cat. Not a simple one though, we need the Schrödinger's cat. Let's take it and put it into a bunker, together with a chemical bomb. The bomb has a 50-50 chance of exploding, so does the cat to survive. We would normally expect, after some time, to find the cat dead or alive. However, quantum mechanics tells us that the cat will be both dead and alive since the moment the bomb should have either exploded or not. This is called quantum superposition. It is a combination of all the possible events that might have taken place, in this case, the cat being alive and dead, both having 50-50 chance of taking place. In the moment we open the bunker's door, the universe has to break the superposition and make a choice from these two, to let the cat live or not. The same principle refers to the wave-particle duality. The pattern we've seen on the screen as a wave was basically a probability graph. For the most intense regions, there was the most intense probability for the particle to arrive, while for the faintest regions the lowest one. The particle traveled as a wave, as a spectrum of probabilities, until it hit the screen. At that instant, the universe had to make a decision, where to place the particle. Same thing goes for electrons revolving around an atom. They don't have a definite position. We can only see the probabilities of where it might be. There is even a probability that the electron might be outside the atom, even though extremely small. It might be anywhere in the universe, but with a corresponding probability. Okay, let's leave the poor cat alone, and move forward to our next discussion point, which is quantum entanglement. Before we start, you need to know that particles have such a property, called spin. It isn't really spin of an object in a classic way, but it's something similar. It can either be orientated up or down. If we have a high source of energy in it, due to quantum fluctuations, some pairs of particles can appear. They have this property, called entanglement. That means that their spins will always be opposite to each other. If one is up, the other will be down. But now imagine that we try to examine such a particle at an vertical angle. It will have a 50-50 chance of being either up or down. Remember, before we measure, the particle has an undefined spin state. So once we measure it, from the range of probability of it being either up or down, the superposition is broken, and one spin way is chosen. At that very instant, the other particle will break its own superposition and become the opposite of the other one. The mind-blowing thing about this is that no matter the distance between the particles, once one spin is known, the others will immediately be uncovered as well, and therefore, the information will be transferred faster than the speed of light. So that's all information I got. Hope you guys and my darling understood.
I did not understand any of this shit, but it was fun and excited to learn something new from a dork nerd like you.
Well, I think I will take it as a compliment.
So hope you guys understood what this nerd told you. If you want more of this video, you check out our YouTube channel and leave a comment about what topic you want to discuss next.
And hope you press or click or smash that like button and see the magic happens tomorrow. And share it with your crush and she will not think you as a nerd rather than she will think as you a genius.
Nerd.